Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I am learning quickly, I don't claim any real expertise. Today, we're looking at the 52nd Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 52 is permutated multiples. It can be seen that the number 125874 and its double 251748 contain exactly the same digits but in a different order. Find the smallest positive integer x such that 2x, 3x, 4x, 5x, and 6x contain the same digits. Alright, so this should, famous last words, be relatively simple with Python. Let's see. 52. Alright. Go back to this problem and steal these two lines that we always like to use. Okay, so I am going to say it's obvious to me that this isn't going to be true for very small numbers. In fact, it's probably a number much larger than this one. So what I'm going to do is I am going to say x equal 100,000. And then while true, which is, as you probably know, always something that you gotta be careful using. I'm just gonna print X down here. While true, we are going to say x plus equals to 1. Our x equals and then we want to have that okay. And then rx dot sort. Rx1 dot sort. Okay, and then if rx equal to rx1 equal to rx2, x3, 4, and 5, break. Okay, so let me go through what I did again here. This is a pretty simple algorithm, and it's entirely possible that, like, doing things this simply will make this very inefficient. But all I'm doing here is I'm saying, okay, add 1 to our x, which we're starting at 100,000. Actually, let's go ahead and start with 0, just to show whether it is efficient. X plus equals to 1, so we actually start with 1, convert that into a string array, convert x into a string array, so that each digit is a string, then multiply it by 2 and do the same thing, 3, 4, 5, 6, sort all of the arrays, and then if all of the arrays are equivalent, break off, and then print whatever x we found. So let's go ahead and see how long does this script take to run. Okay, so we actually got there immediately. Like, that took half a second tops, and the number is a 6-digit number, not very much larger than the example number they gave us. Let's see if it is correct, and that is the right answer. So there we go. That one was short and sweet. And in another language, this probably would have been much, much more difficult, but since Python has these built-in functions and list comprehensions is what this is doing here, it's very simple in Python. So I'm going to call it there for today, and I'll see you in the next one.